Bismillahirrahmanirrahim. Welcome to my YouTube channel Kiki Math. Today I am going to share solution of physics grade 9th Cantab publisher. Number 9 topic pressure. Multiple choice questions. Question number 1 if the force is constant what happens to pressure as area increases? Option A pressure remains unchanged. Option B pressure increases. Option C pressure decreases. Option D pressure doubles. Correct answer is C pressure decreases. If you push down on the top of a sealed syringe filled with water, in which direction is the force exerted by the water on the syringe's side? Option A upwards, option B downwards, option C sideways at right angles to the surface, option D in the direction of the push. So the correct answer is option C sideways at right angles to the surface. This is a direct application of Pascal's principle, which states that pressure applied to a fluid in a closed container is transmitted equally in all directions. Question number 3. During an experiment, a student notices that when pressing on a sealed air filled balloon, the balloon expands uniformly in all directions. This observation demonstrates that the force due to pressure in a fluid is option A directed towards the bottom of the balloon only, option B greatest at the sides of the balloon, option C exerted equally in all directions at right angles to the surface, option D non existent as air cannot exert force. Correct answer is option C exerted equally in all directions at right angles to the surface. Question number 4. Which of the following phenomena is used to justify that the atmosphere exerts pressure? Option A. A balloon deflating when taken to a higher altitude. Option B. A balloon inflating more at higher altitudes. Option C. A vacuum not affecting the shape of a balloon. Option D. Air not having weight. So the correct answer is option A. A balloon deflating when taken to a higher altitude. This phenomena demonstrates that the atmosphere exerts pressure as the balloon ascends to a higher altitude. The atmospheric pressure decreases, causing the balloon to deflate. Question number 5. What happens to atmospheric pressure as an airplane ascends to cruising altitude? Option A. It remains constant. Option B. It increases. Option C. It decreases. Option D. It fluctuates unpredictably. So the correct answer is option C. It decreases. Atmospheric pressure decreases with altitude. This is why aeroplanes need to be pressurized at high altitudes to maintain a comfortable cabin environment. Question number 6. How might a change in atmospheric pressure be indicative of an approaching weather system? Option A. A significant drop in pressure suggests clear sunny skies. Option B. An increase in pressure indicates an approaching storm. Option C. A sudden increase in pressure signals the likelihood of rain. Option D. A drop in pressure often precedes the arrival of a storm. So the correct answer is option D. A drop in pressure often precedes the arrival of a storm. A drop in atmospheric pressure typically indicates that a low pressure system is approaching. Low pressure systems often bring stormy weather such as rain, wind, and sometimes even snow. Question number 7. A liquid barometer is taken from sea level to the top of a mountain. What is expected change in the barometer reading, assuming no other changes in a weather conditions? Question Option A, the reading will increase. Option B, the reading will decrease. Option C, the reading will stay the same. Option D, the reading will become erratic and unpredictable. So the correct answer is option B, the reading will decrease. Explanation As you ascend higher, the atmospheric pressure decreases. This means there is less weight of air pushing down on the liquid in the barometer, causing the liquid level to fall. Question number 8. What happens to the liquid level in a barometer when atmospheric pressure increases? Option A. The liquid level rises. Option B. The liquid level falls. Option C. The liquid level doesn't change. Option D. The liquid level fluctuates rapidly. So the correct answer is option A. The liquid level rises. Explanation When atmospheric pressure increases, there is more weight of air pushing down on the liquid in the barometer, causing the liquid level to rise. Question number 9. How does the pressure of water increase at a depth of 10 meters in the ocean compared to the pressure at the depth of 5 meters, assuming uniform water density and gravitational acceleration? Option A, it is the same. Option B, it is twice as much. Option C, it is half as much. Option D, it is 4 times as much. So the correct answer is option B, it is twice as much. Explanation Pressure in a fluid increases linearly with depth. This means that for every additional meter of depth, the pressure increases by the same amount. Therefore, if the depth doubles from 5 meters to 10 meters, the pressure also doubles. Question number 10. If the density of a liquid is increased but its depth remains the same, what happens to the pressure at that depth? Option A, the pressure decreases. Option B, the pressure remains unchanged. Option C, the pressure increases. Option D, the pressure becomes zero. So the correct answer is option C, the pressure increases. Explanation Pressure in a liquid fluid is directly proportional to its density. If the density increases while the depth remains the same, the pressure will also increase. Question number 11. What is the primary purpose of a manometer? Option A, to measure the volume of a container. Option B, to measure the pressure of a fluid within a system. Option C, to measure the temperature of a gas. Option D, to measure the density of a liquid. So the correct answer is option B, to measure the pressure of a fluid within a system. Explanation A manometer is a device specifically designed to measure the pressure of a fluid, typically by comparing it to a known reference pressure. Question number 12. Pascal's law states that pressure applied to a confined fluid is transmitted. Option A only to adjacent areas. Option B at half the original force throughout the fluid. Option C undiminished to every part of the fluid and the walls of its container. Option D only in the direction of gravity. So the correct answer is option C undiminished to every part of the fluid and the walls of its container. Explanation Pascal's law states that pressure applied to a confined fluid is transmitted equally in all directions. This means that the pressure applied to one point in the fluid is felt equally throughout the fluid and against the container's walls. Question number 13. In a vehicle equipped with hydraulic brakes, when the driver applies force to the brake pedal, how is the force transmitted to the brakes? Option A through mechanical linkages only. Option B by electrical signals. Option C it is transmitted as increased pressure through the brake fluid. Option D directly and only to the nearest brake. So the correct answer is option C. It is transmitted as increased pressure throughout the brake fluid. Explanation: in hydraulic brakes, the force applied to the brake pedal is transmitted through the brake fluid to the brake calipers. This increased pressure causes the brake pads to press against the brake rotors, slowing or stopping the vehicle. Question number 14. What unit is pressure typically measured in? Option A newtons, option B pascals, option C kilograms, option D meters squared. So the correct answer is option B pascals. Question number 13. A barometer reading a sudden fall in atmospheric pressure indicates option A sunny weather, option B a storm is likely, option C stable weather conditions, option D snowfall. So the correct answer is option B a storm is likely. Question number 14. According to Pascal's law, if pressure is applied to an enclosed fluid, the pressure increase is option A only at the point of application, option B unevenly distributed, option C transmitted undiminished to all parts of the fluid, option D reduced by half throughout the fluid. So the correct answer is option C transmitted undiminished to all parts of the fluid. Question number 15. If the density of the liquid in a manometer is 13,600 kg per cubic meter density of mercury and the liquid rises by 0.05 meters, calculate the pressure difference measured by the manometer. Option A 6800 pascals, option B 680 pascals, option C 68 pascals, option D 6.8 pascals. So the correct answer is option B 680 pascals. Question number 16. On which factor does the pressure at a certain depth of a liquid depend? Option A the pressure of the liquid, option B the depth of the liquid, option C the salinity of the liquid, option D the color of the liquid. Correct answer is option B the depth of the liquid. Short questions. Question number 1. Describe how pressure changes when a force is applied to a smaller area. Its answer is when a force is applied to a smaller area, the pressure increases. This is because pressure is defined as force divided by area. If the area is smaller, the same force will result in a higher pressure. Question number 2. Why does a suction cup stick to a flat surface due to pressure? Its answer is a suction cup sticks to a flat surface due to atmospheric pressure. When you press a suction cup onto a surface, you create a partial vacuum between the cup and the surface. This means that the air pressure inside the cup is lower than the atmospheric pressure inside. The higher atmospheric pressure pushes down on the cup, holding it firmly in place. Question number 3. Describe the physiological effects of decreased atmospheric pressure at high altitudes. Its answer is decreased atmospheric pressure at high altitudes can lead to several physiological effects. Hypoxia. This is a condition where the body's tissue don't receive enough oxygen. Symptoms can include shortness of breath, fatigue, headache, and dizziness. Increased blood pressure. The body's response to hypoxia is to increase blood pressure to deliver more oxygen to the tissue. Pulmonary edema. In some cases, the increased pressure in the lungs can lead to fluid buildup known as pulmonary edema. Altitude sickness. A combination of these effects can lead to altitude sickness with symptoms such as nausea, vomiting, and difficulty sleeping. Question number 4. Describe how Pascal's law is applied in hydraulic systems like car jacks and brakes. Pascal's law states that Pressure applied to a fluid in a closed container is transmitted equally throughout the fluid. In hydraulic systems, this principle is used to amplify force. Car jacks, a small force applied to a narrow piston is transmitted through the hydraulic fluid to a larger piston. This larger piston exerts a greater force lifting the car. Brakes, the pressure applied to the brake pedal is transmitted through the hydraulic fluid to the brake calipers. This pressure forces the brake pads against the rotors, slowing or stopping the car. Long questions. Question number 1. Design and experiment using simple materials to demonstrate how pressure is transmitted equally through a fluid in all directions, and use this setup to explain the concept of hydrostatic pressure. Materials: clear plastic container, water, several small holes drilled at different depths in the container, colored liquid, for example, food coloring. Procedure: fill the container with water, add a few drops of colored liquid to the water, observe the colored liquid flowing out of the holes. Explanation: the colored liquid will flow out of all the holes at the same height, regardless of their position on the container. This demonstrates that pressure is transmitted equally through a fluid in all directions. Hydrostatic pressure is the pressure exerted by a fluid at rest. It increases with depth due to the weight of the fluid above. The experiment shows that this pressure is transmitted equally in all directions, explaining why the colored liquid flows out of the holes at the same height even though they are at different depths. Question number 2. Considering the density of air decreases with altitude, explain how this affects the lift generated by airplane wings at higher altitudes and the performance of the aircraft's engines. Density of air and lift. As altitude increases, the density of air decreases. This means there are fewer air molecules per unit volume. Airplane wings generate lift by creating a difference in pressure above and below the wings. This pressure difference is influenced by the density of the air. With low air density at higher altitudes, the lift generated by the wings is reduced. This means the airplane needs to increase its speed or adjust its angle of attack to maintain the same lift. Density of air and engine performance. Air is essential for the combustion process in airplane engines. With lowered air density at higher altitudes, the amount of oxygen available for combustion is reduced. This can lead to decreased engine power and thrust. To compensate, engines may need to adjust their fuel to air ratio or use turbochargers or superchargers to force more air into the engine. Please like my video to motivate me. Let me know in the comment section which type of content you want regarding physics and maths. Don't forget to share it with your friends and subscribe my channel as well. Thank you.